Okay, this is January 2025, Unit 5 paper. Which species cannot act as a ligand in the formation of a complex ion? So I told you that ligand is the one which is going to have lone pair of electron. So ligand can be negative and ligands can be neutral, but they cannot be positive, of course. So if you can see carbon monoxide, it has lone pair of electron. Okay. If you can see OH minus, it's having a minus charge, negative charge, so it's a ligand. And if you can see option D, in this option you can see nitrogen atom. On this nitrogen you can see a lone pair of electron. So as compared to B, C, and D, if you are going to see option A, this is ethane. If you would be drawing the dot and cross diagram, so you will not see any lone pair of electron in this. So C2H6 cannot act as a ligand. Okay. Question number two, an aqueous solution of a transition metal ion absorbs frequencies of light corresponding to green, yellow, and red. Okay. So which ion is likely to be in the solution? Absorbs frequencies of light. Remember, when they are going to absorb these frequencies of light, so means that we cannot see this color. It's understood. Because when something emits frequency, so we can see that color. Emitted color we see. We cannot see absorbed color. So green, yellow, and red. We cannot see these colors. Okay. So manganese is colorless. You know that because this is not a transition metal. Okay. This is not a transition metal. No, sorry. Mn2 plus is not a transition ion, or you can say, no, I think so. We had scandium and zinc. Yeah, they are not transition metals. Scandium 3 plus and zinc 2 plus, because they are not going to have any unpaired electron. They are not having partially filled d orbital in its ionic form. But Mn2 plus, Mn2 plus, if you remember, we had KMnO4. So we used to say KMnO4 changes into Mn2 plus. So it would be from purple to colorless. It would be from purple to colorless. Okay. So Mn2 plus is colorless. And if you can see cobalt 2 plus, cobalt 2 plus. Okay. And if you can see nickel, nickel is green. You know that nickel is green. Okay. And copper is blue color. Copper is of blue color. So when something absorbs green, yellow, and red, so it's going to emit blue color. It's going to emit basically complementary colors are observed. Basically, complementary colors are observed. Okay. So so then why not option A is correct? So you will say that um, because green, when something absorbs green and yellow color, so as a result, it would be emitting pink color. And why B is incorrect? Because when something absorb, green and yellow color, okay, so it won't absorb red color. Remember, it won't absorb red color. Okay, and also nickel 2 plus, same explanation, because it's not going to absorb green color, so it's green. Okay, it's green. And cobalt 2 plus is red. Okay, Mn2 plus is pale pink. So remaining option is D, that is copper. So copper is not going to absorb blue color. Okay, copper is not going to absorb blue color. So it would be emitting this blue color and it would be absorbing all the colors. Remember. So you need to memorize at which frequency it's going to absorb what color. Okay, so when we were discussing transition metal, so I told you this circle. In that circle, it was written that the complementary colors are observed. If it's going to absorb green color, let's say, so the complementary color of the green would be red, let's suppose. So we would be observing red color. So complementary colors are observed. So this question is related to complementary colors topic. Okay. The first five ionization energies of four elements are shown. Which are the ionization energies of a transition metal? So you know what's the concept? What's the concept? Concept is that the ionization energies of a transition metals are generally the same. Similar ionization energies. You know why? Because they all are having electron in d orbital, d1, d2, d3, d4, d5, d6, d7, d8, d9, d10. All electrons are in the d orbital. So we have to select the option in which we can see the similar ionization energies. So how can you know this? You can subtract the two ionization energies and you can see the difference. So the option in which you will see the minimum difference, that would be the correct option. So if you are going to subtract this one, and this one, just like that, same goes with B, same goes with C, and same goes with D. Okay, same goes with D, like that. So can you tell me what's the difference between first and second ionization energy of A? Yes, and then B, and then C, and then D. Yes.
There's a huge jump between the first and second one, so that means that the electron is removed from the first
Yeah,
group.
exactly. So this is incorrect. This is incorrect because large jump between first and second. So it corresponds to group one. It corresponds to group one. So this is not possible. They are transition metals. And then what about B?
In B, there's a jump between the third and fourth ionization energy,
Exactly. So this is
so
group
that
three.
means the group, yeah.
Exactly. So this is incorrect. They are not transition metal. And it's a big jump
And
between
it's
second and
C,
third.
yeah, so that means it's removed from group two
Yeah,
of
exactly.
transition method.
And then in option D, uh, you can see there is no big jump. They are similar. So yeah, this is transition metal. Okay. What is the color of the VO2 plus ion in aqueous solution? First of all, you have to find out the charge of vanadium in this one because the color is depending upon the charge. VO2 plus means that V oxygen is equal to plus 2 and V is equal to plus, like vanadium is plus 4 in this, and when vanadium is plus 4, so it would be blue. Which statement about a catalytic converter is used to reduce toxic emissions from internal combustion engines is not true. The catalyst contains platinum. Yeah, this is correct. This is correct. Catalyst is platinum, which is a metal, which acts as a catalyst. CO and NO are absorbed by the catalyst. Yeah, that's true. That's that's true. CO and NO. CO and NO are absorbed by the catalyst. Right. And C is correct, yeah, because after the reaction, desorption of CO2 and N2 take place. Of course, CO would be converting into CO2 and NO, oxide of nitrogen, would be converting into N2. So harmful gases have been converted into harmless gases now. So C is true, yeah. Heterogeneous. How can we say that this is heterogeneous catalyst? So I told you, when you can see gases in the reactant side, and a catalyst is solid, like different phase. Like you can see totally different phase. So this is known as heterogeneous catalyst. This statement is correct. This statement is correct. This statement is correct. And then statement B, statement B is not correct. Which statement about a catalytic converter used to reduce toxic emissions from internal combustion engines is not true. Basically, they react with each other. They react with each other. If you remember, that was this was an equation just like that. Okay. So they are reacting in an internal combustion engine or catalyst is providing its surface. Catalyst is providing its surface. So this statement is not true. They're saying CO and NO are absorbed by the catalyst. It's not true. They will react, and as a product, they will release carbon dioxide and nitrogen gas. Which of these pairs of elements are both transition metals? Scandium is not transition metal, of course. Titanium, scandium again, zinc is again. So B
Right,
is
so
correct.
for the fifth
Yeah.
question, how would we know whether it's heterogeneous or homogeneous? We don't have any equation or
So you
anything.
have to, you have to memorize. Like if you remember in rate of reaction kinetics. So we had this reaction when Fe2 plus is using as a catalyst and I minus is going to react with thiosulfate S2O72 minus. So if you can see ions are aqueous and this is also aqueous. So when all are aqueous, so this is homogeneous. If you remember Haber process, nitrogen gas was reacting with hydrogen gas, it was producing ammonia gas, and the catalyst was iron solid. So this that was also heterogeneous catalyst. And if you remember hydrogenation, in that we had alkene that was a gas. So we were adding hydrogen into that and as a result ethane were produced. Okay, ethane were produced, that was also a gas, but what was the catalyst? Nickel catalyst, that was solid, so that was also heterogeneous catalyst, that was also heterogeneous catalyst. Okay, so we must have some examples of homogeneous and heterogeneous catalyst. Okay, so this is also one of them because in catalytic converter we have a honeycomb structure. In that structure, like platinum is fitted. Of course platinum is a metal which is a solid. So and in catalyst different gases are going to enter into that, and as a result that catalyst is going to convert that harmful gases into the harmless gases. So that's why this is also an example of heterogeneous catalyst. And six is very easy, of course, because scandium and zinc, they are not transition metals. So except these two, all would be the transition metal. They are saying which of these pairs of elements are both transition metals. Of course, B is correct. Then what do you think about that? Question number 7. I told you whenever the coordination number is 4, it may be square planar and it may be tetrahedral. So they are saying what are the shape of the complexes copper chloride and platinum. Yeah,
Tetrahedral and square planar. See,
yeah, good. Tetrahedral and square planar. It has a negative charge. Negative means there would be a repulsion. So the particles should be far away from each other in order to avoid repulsion. So the bond angle would be higher. In square planar, the bond angle is the bond angle is 90 degrees, and in this the bond angle is 109.5 degree. Which is correct about standard electrode potentials? Which is correct about standard electrode potentials? So this is a statement that you need to know. Option B, this is a statement that you need to know. E of cell is proportional to ln k and delta S total. Like it's an entropy. It's an entropy. Like when ln k increases, so the E of cell, electrode potential of the cell is going to increase. And when the entropy increases, they are talking about the total entropy, system plus surrounding. So when the total entropy increases, so the cell potential increases. So means option B is correct. Which reagents are mixed with hydrochloric acid to produce the benzene diazonium ion? Which reagents are mixed with hydrochloric acid to produce the benzene diazonium ion? So A is this, A is this reactant, and B is like this one is the same thing, but NO2 is attached. The same thing, but NO2 is attached. The same thing, but NO2 is attached. Okay. And so if you remember, for the diazonium salt, we need amine, not NO2 group. So this is clear. Of course, option B and C can never be a correct option because the reactant is wrong. It may be A, it may be doctor, D for doctor. So, you know, we were adding NaNO2 plus HCl. It was producing HNO2. It was producing HNO2, okay, and NaCl. So that was nitrous acid. That was nitrous acid that we were using to produce diazonium salt. So of course option A is correct because in option B we have NaNO3. We have NaNO3. It's wrong. It's wrong. So means that you must memorize all the reagents and conditions, especially how to produce azo dye. So before going to do azo dye, we generally produce diazonium salt, and then furthermore the diazonium can react with the reagent and it can produce azo dye. And to produce diazonium salt, we must have amine like aminobenzene and NaNO2. Okay, like option B. Yes, which reagents and reconditions are used to prepare the yellow dye 4-phenyl diazenyl phenol from the benzene diazonium ion? Yeah, phenol dissolved in acidic solution? No, 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 no. Phenol should be dissolved in a basic solution. Remember, should be dissolved in an alkaline solution. So acid wale option wrong. This is wrong. This is wrong. Then we have to check B and D. Then we have to check B and D. Of course, option D is correct. You know why? Because in option B, the temperature is higher. This is the room temperature. At this temperature, the diazonium is very unstable. Already it's going to have 4 bonds with the nitrogen. That is not possible. It's highly unstable. It's highly unstable, remember. So that's why option D is correct. Why? Because the temperature is lower. So at lower temperature, it would remain. It would exist like this ion would exist. So this is more stable condition. That's why D is correct. Question 10 says, which sequence describes recrystallization? Dissolve in the minimum volume of cold solvent, filter to remove insoluble impurities, then add hot solvent and filter to remove the soluble impurities. They are saying describes recrystallization. Describes recrystallization. Then option B says dissolve in the minimum volume of hot solvent. Okay, hot solvent means that the solubility would be very high. Of course, the solvent is hot. Okay, they were saying in option A, dissolve in the minimum volume of cold solvent. How is that possible that substance is going to dissolve in a cold solvent? Wrong. Okay, wrong. Then all are hot, hot, hot. So then we have to check B, C, and D. In B, they are saying dissolve in the minimum volume of hot solvent, filter to remove the soluble impurities. Okay, filter to remove the soluble impurities. What are they saying? Filtration means when we are going to separate insoluble particles. Oh my God, they are saying filter to remove soluble impurities. Okay, so this is incorrect. Okay, soluble impurities. This is incorrect. And then option C says minimum volume of hot filter to remove the insoluble. Yeah, that should be correct. Okay, then we have to check D as well. In D, they are saying filter to remove this. Oh my God, again. So that's option C is correct. Okay, major error. Major error. Identification is very easy. Identification is very easy. They are not similar options. They are very different options. So the student would stuck in those questions where they see the similar answers. They are not similar answers. Synthesis of aspirin from phenol is shown. Okay. What mass of aspirin is formed from 23.5 grams of phenol? So first of all, they are saying yield is 80% and then yield is 75%. So you have to first of all find out the mass of this one and then the mass of this one. Okay. And they have given you the mass of aspirin that is 23.5 grams, like this one. So then what you would be doing to find out the mass of aspirin finally? Mhm. Mhm. Mhm.
23.5 is the theoretical yield, so we can find the actual yields using the information in the diagram.
So then what would be the answer? Yes, yes. Very easy.
Is it 33.8?
First of all, you are supposed to find out the moles. 23.5 divided by 94, that's gonna be um 23.5
0.25.
divided by 94, 0.25. Then I'm going to take 80% of this one. So that would be 0.2 mole of this one. Then I'm going to take 75% of this one, 75% of this one. So that would be 0.15 mole of aspirin. Then I'm going to multiply this by Molecular mass, that is 80. I'm getting 27. So answer is B. Simple. Answer is B. Okay.
Yeah, okay.
Yes. An 8.4 gram sample of a hydrocarbon formed 26.4 gram of carbon dioxide on complete combustion. What is the molecular formula of this compound? Molecular formula of this compound. So, uh, you know, this is empirical or molecular? What do you think? Empirical or molecular? How can you identify this one? Empirical or molecular? I'm talking about A. Its simplest formula already. It's the simplest one. It's empirical, not molecular. Straight away, this is incorrect option. Straight away, that this is incorrect option. Then we have to check B. Yeah, B is molecular formula. C is molecular formula. D is molecular formula. Okay. So then what would so then so then what would I do? Um, first of all, First of all, I would be finding out the moles of a sample of hydrocarbon. Okay, and first of all, let me write down the equation. When C6 reacts with oxygen, it produces carbon dioxide and water. You have to balance the equation. 6 CO2 and 3H2O. Then you have to balance oxygen. Okay, then you have to balance oxygen. So of course, oxygen would be 3, and then 6 2s are 12. 12 plus 3 is 15, right? So it would be 15 by 2, right? 7.5. Okay, 7.5 oxygen. Is that balanced? Yes or no? Okay.
No, we have
Then
to
you have to what?
turn it into a whole number. 7.5.
Sorry.
We have to turn 7.5 into a whole number, so you have to multiply the entire equation by 2.
No, 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 no. Yeah, like this is not about the question that they are asking the balanced chemical equation. We have to find out the moles. So I'm going to balance for myself to make it easier. So this is balanced chemical equation. Then we have to balance the C option as well. C2H6 reacts with O2. It's going to form CO2 and water. So 2 CO2 and 3 H2O, 2 2s are 4, 4 plus 7, 7, 7, 7. So that's going to be 3.5. And then I'm going to balance option D as well. That would be C6H12 plus O2, and it would give you carbon dioxide and water. So 6 and then 6, 6 and then 6, and then of course that would be 9. Okay. So then I'm going to solve option B because A is completely incorrect. So what I would be doing, first of all, I would be finding the moles of C6H6. I'm going to solve option B, okay? Mole is equal to 8.4 divided by the molecular mass of C6H6, that is 84. I think so. Can you tell me the molecular mass of this one? Mm-hmm.
78.
78. Oh, sorry. Yes. And what is the mole?
Zero 0.12.
0.12 mole.
0.11. 11.
1 1 mole. 1 mole. So then ratio between C6H6 and CO2 is 1 is to 6. Ratio between C6H6 is 1 is to 6. Okay. So then I got the moles, that is 0.11. What would be the mole of CO2? That would be X. So X is equal to what? 0.66 mole. Am I right?
Yes.
And I am going to multiply this with the molecular mass of CO2, that is 44. What's the answer?
29.04.
29 point.
04.
So, but the given mass is this. So it's incorrect. Then same goes with C. Same goes with C. I'm going to solve the moles of, I'm going to find out the moles of your hydrocarbon, that is C2H6. So it would be mass over molecular mass. What is the molecular mass of C2H6? I think so. It would be 30.
Yeah.
So 8.4 over 30. What is the mole?
0.28.
0.28 mole. So I'm going to multiply this by 2 because the mole ratio between C2H6 and CO2 is 1 to 2. So I would be getting the moles of CO2, and then I'm going to multiply this with the molecular mass of CO2, that is 44. What's the answer? Are you getting 26.4?
No, it's 24.6.
This is incorrect. Then same goes with the mole of hydrocarbon, that is 8.4 divided by the molecular mass of C6H12. What is the molecular mass? I think it would be 84. Yeah, maybe. Yes or no?
Yeah, 84. Yeah.
84. What's the mole?
0.1.
0.1 mole multiplied by 6. Multiplied by 6 because ratio between C6H12 and CO2 is 1 is to 6. So I would be getting 0.6 mole of CO2. Then I'm going to multiply this by 44. What's the answer?
26.4.
Exactly. So that's why the answer is D, because it's producing 26.4 grams of carbon dioxide. Okay, then question number 13 says, what are the volumes of oxygen required and carbon dioxide? They are asking the volume of SO, like O2 and CO2 produced at room temperature and pressure on complete combustion of 5.8 grams of butane. So butane is C4H10 reacting with O2. It is producing CO2 and water. I'm going to balance this equation. It's 4 and it's 5. So 8 plus 5 is 13. So it would be 13 by 2. Then I'm going to find out the moles of butane. That's gonna be mole is equal to 5.8 divided by the molecular mass. That is, molecular mass of butane is
58. It's given.
given. Oh, yeah, 58. Okay. Answer is 0.1.
Yeah.
Okay. And the mole ratio between this and oxygen is 1 is to 13 by 2 means 6.5. 1 is to 6.5. I have the moles, that is zero point 0.1. What would be the mole of oxygen? X is equal to zero point 0.1 multiplied by 6.5. What's the answer?
0.65.
0.65
Yes.
multiplied by 24. Mole multiplied by the volume. Mole multiplied by the molar volume. That's going to give you
15.6.
volume. 0.15.6,
15.6.
right?
Yes.
Yeah. So option A and option D may be correct. Then you have to check the volume of CO2. So the mole ratio between C4H10 and carbon dioxide is 1 is to 4. And I got the mole that is zero point 0.1. It's gonna be X. So X is equal to zero point 0.4 multiplied by 24. So the answer would be 9.6. Option A is correct. Okay.
Yes.
What is the repeat unit of the water soluble polymer polyethanol? Ethy means E. E for alkene and all means alcohol. So water soluble. They are saying water soluble, dissolved in water. They are saying all. They are saying all. It has only one OH. It has only one OH. So of course B is correct. Of course B is correct. They're not saying diol. They are not saying triol. They are not saying tetraol. So that's why B is correct. In the repeat unit, only one OH should be there. That's why. A repeat unit for a polyamide is shown which pair of monomers makes this polymer. Uh, okay. So if you can see, this is the first repeat unit and this is another. Like in the same repeat unit, we can see the two different monomers that are joined together. So that would be NH, that would be OH. Of course, it's carboxylic acid. And also that would be H and this would be OH. So I can see uh, option A, 100% matching. This is the one, and this is going to match with this one. That's why option A is correct. Four compounds, four compounds, W, X, Y, and Z are shown. Which compound is an optically active amino acid? Optically active amino acid. It should have chiral center. It's not chiral, same group. It's not chiral, same group. It's not chiral, same group. Y is a chiral. Y is a chiral. So optically active amino acid would be Y because it's going to have a chiral center. Chiral center is the one in which the four different groups are attached with the central carbon. So that's why this is chiral carbon and that's why it's optically active. Which compound does not have the same number of peaks in the low resolution and in the low resolution proton NMR and in the carbon 13 NMR spectrum does not have the same number of peaks. Okay. First of all, I'm going to see um, these six hydrogen atoms are similar. So it's going to give you one peak. I'm writing 1, 1. And this is the second peak and this is the third peak. So so three peaks in proton NMR. And if you are considering carbon, so 1 and 1, and 1, 1, 2, and then 3. So three peaks in carbon NMR. Three peaks in carbon NMR. Okay, so they are having the same peak. And if you are going to consider option X, so these are one peak, and these two hydrogens are having the same environment, second peak, and this would be the third peak. Okay, so three peaks in proton NMR, three peaks in HNMR, and carbon one, carbon, they are the same, one peak. This is another, this is the third one. So same peaks in the carbon 13 NMR. Then if you are going to check why, same, then one, same, and then same. Four peaks. Four peaks in HNMR. Carbon 1, 2, and 3. Only three carbon it has. So three peaks in carbon 13 NMR. So what they were saying, which compound is which compound does not have the same number of peaks? So it is only Y. It is only Y. And what about Z? If you are considering proton NMR, so 1, 2, 3, 3, and this are the same. So 3 and 3. 3 peaks in proton NMR, and 1, 2, and these carbons are same. So 3 peaks in carbon NMR. Yeah, option C is correct. Only Y is the compound which is going to give you the different peaks in proton NMR and carbon NMR. Okay. Like working is required, of course, but they're not very difficult questions. Asparagine is an amino acid. What will be the structure of this in an aqueous solution at pH 2? So, amino acid exists in the form of Zwitter ion at the neutral pH, of course. They are known as isoelectric point, where the you can say Zwitter ion exists. But when the pH is 2, so I can say that it's going to be an acidic pH. So means that H, I'm going to provide protons. I'm going to provide protons. So of course, proton would affect the basic part. It won't affect the acidic part. Okay, it would be affecting the basic part. So of course, it's amide. It's what? It's amide. It's not basic. It's not basic part. Amide is not a base. Okay, only amine is a base. Remember, I told you when we were discussing organic nitrogen compounds. You know why? What's the reason? What's the reason? Because in amide, electron pair is delocalized into this system. So the lone pair is not available. So we generally define base that it's a lone pair donor. When the lone pair is not available, so what it would donate? It's not a basic part. So that's why amine is a basic part. So proton will affect this part. It would be having and it would be becoming NH3. You know why? Because it's going to gain proton. Base is a proton acceptor. It would be NH3 plus. So we have to, yeah, B is your correct option. Why not C? Because in this option also you can see NH3 plus. No. Sorry. B is wrong. C is correct because in B you can see this one. You can see this one. Only, only the basic part will be affected by this one. But, what is this? What is this? No, option C is also wrong. I would say that option D is the best option. Okay. So the point is that only the proton will affect the basic area. And the basic area is what? It's an amine. In a high resolution proton NMR spectrum of asparagine, what would be the splitting pattern for the protons indicated by the arrow? So we have to check the neighbors. We have to check the neighbors. Only one hydrogen in the neighbor. Only one hydrogen in the neighbor. Neighbor of this one, of course. So it's a neighboring hydrogen. It's a neighboring hydrogen. I would be applying n plus 1 rule. I would be applying n plus 1 rule. So neighbor plus 1 is equal to 2. So I would see the doublet. I would see the doublet. So of course B is correct. Simple. Whenever the examiner asks about the high resolution NMR spectrum, so you have to check the neighbor. You have to check the neighbor. Okay. Then, okay, electrochemistry. The standard EMF of the cell shown was measured. Identify by name or formula the substances needed in the salt bridge and the right hand half cell. Include concentrations where appropriate. Salt bridge containing a solution of the compound. So what would be present in the salt bridge? What would be present in the salt bridge? So remember a saturated solution of potassium nitrate. A saturated solution of potassium nitrate. Okay, this is the chemical which is present in the salt bridge. Saturated saturated solution saturated solution of potassium nitrate. Saturated solution of potassium nitrate. Made of electrode made of. Okay, so this is the zinc. Of course this would be iron 3 plus solution. So electrode is made of what? I told you, I told this is very important concept. I told you whenever you have, whenever you have the two ions, whenever you have the two ions in the same solution, whenever you have the two ions in the same solution, so the electrode should be made of platinum. So the electrode should be made of platinum. That's the main point. And the solution containing the compounds, that is C, of course, solution of Fe2 plus and Fe3 plus, the dual solution. Okay, solution of Fe2 plus and Fe3 plus. Okay, of course, Fe2 plus comes from FeSO4 and this from FeSO4 3. It's all about the charges. It's all about the charges. Okay. Why a salt bridge is used rather than a wire? Because, in a wire, we have electrons. In a wire, we have electrons. Okay. Or, and, this question was of, yeah, okay. So, why a salt bridge is used rather than a wire? Because the wire contains electrons. We need ions. We need ions. So the ions can flow through a salt bridge. Through a salt bridge. Okay, ions cannot flow through a wire. Remember, wire is made of metal. Metal has delocalized electrons. Metal has delocalized electrons. So the point is that through the wire, ions cannot flow. Like if I'm asking why sodium chloride is a good conductor in aqueous state, you cannot say electrons are free to move. No, this is an ionic compound. Ions are free to move. So we have to We have to make the ions to flow from one place to another place. So we need some sort of medium. So that medium is a salt bridge, not a metal wire. Ions cannot flow, but they can flow through salt bridge. Okay, it's very simple.